at a relationship that the movement, maybe looks like something like this, where we notice that the change in this x-axis actually doesn't really have very much impact in the change in the y-axis, then we'd say that has a weak correlation, right? Those things don't really seem to have a great impact on, one doesn't have a great impact on the other, or even, you can just have kind of a very flat correlation, so it's like where we can almost say there's almost no relationship between what's on the x-axis and what's on the y-axis. And so in that instance, that can definitely give us some kind of good feedback about the kind of things that might have a relationship. Now, I almost always have my students in class repeat this aloud, and maybe while you watch this video, you can repeat it aloud as well. But basically, what I want you to see here is that just because there's a correlation, that doesn't mean we don't necessarily have a causation. So repeat this out loud. Correlation does not equal causation. All right, that's very important for you to understand, because oftentimes we read these articles on Google or on Hotmail, whatever, and they say, well, researchers have discovered that eating an apple every day will make you a more productive person, right? And that's not usually, it's just a correlational research design they use, as they just had people eat more apples and saw how productive they were. And while there may be some relationship there, it doesn't actually equal causation, not until we actually do a true experimental research, which is kind of where we're going to here in a moment. So I hope that gives you some clarity. Okay. And kind of moving forward here, now we're moving into what I would call what is called the experimental design, and I would call this kind of a true experiment, if for lack of a better term, mostly because this is the first time that we're actually going to manipulate something in the situation in order to test our hypothesis. Okay, so basically, I want to determine, let's say I'm looking at a new drug that I found, okay, and for blood pressure, a new drug that I created for blood pressure. In order for me to truly test out if this new drug has an impact on someone's blood pressure, I need to run an experiment where I actually manipulate something in the environment. All right, not just observing what's happening in the environment, not just kind of looking at, if there even is a relationship, but I'm actually going to manipulate something in order to prove that this drug actually will cause changes in that person. So what we want to look at here is the different type of groups here. We have our treatment group, our experimental we have our treatment, and we have our experimental group versus our control group. And so in every experimental design, we need to have an experimental group that actually receives the treatment, the new drug, in this example I'm giving you, and the control, right, which is going to receive something like a placebo, or maybe just they're going to just be on a wait list waiting to receive treatment. And we want to see the differences that occur here. Okay, so let me again kind of open this up here, and let's look at, okay. Oops. So looking at this experiment here, let's say I go to that drug example I keep using, right? In this scenario, let's say I have people that I'm going to collect from a community in order to test my new drug. Now, first of all, just like I talked about in the class, we have to make sure we're gathering a sample of our population. Now, when I gathered people up at the front of the class and I said, do the 6 students or 8 students I had standing at the front of the class really represent Amarillo? What we found is that they really probably don't, right? I mean, what percentage of the population, what percentage of any population is going to have a college degree or even go to college in the first place? All right, it's smaller for sure. But then, when we look at things like, what's the proportion of men versus women who go to college? We're going to see that women are more likely to go to college than men. So the few people we had standing at the front of the class probably aren't the best representative of Amarillo or even just of the greater of our nation in general, right? But it is important if, let's say, we're to do an experimental design on high blood pressure. Again, I want to make sure I gather a sample, a true sample of my population, but I also want to make sure it's random enough that I'm not trying to kind of lean what's going on in my experiment toward the way I want to versus basically I'm not trying to manipulate my results based on who I put in group A versus group B. Okay, so let's look at my little chart here to the left. So let's say I have two groups come in that I've actually got an accurate sampling of that population, and I'm going to go ahead and test their blood pressures after they started the treatment. And I use quotations here for treatment because, again, one group may have treatment, whereas the other group gets a placebo or a sugar pill is what we'll call it. And so let's say after a while I have these groups come in, and let's say the blood pressure for group 1 who received placebo was something like, 165 over 98, 170 over 95, 165 over 90, and then finally we have something like 180. Sorry, 180 over 99. Okay, so that's group A, right? So I had people come into my group, and they either went to one side or the other. And those in group A, after a period of time being on the sugar pill, this is their blood sugar results, or not their blood sugar, but their blood pressure results. And then let's say on the other group, again, kind of understanding the concept of blood pressure, 120 over 80 is healthy. So let's say I have a 120 over 80, for my first person, and then let's say I have a 125 over, 125 over 79, 119 over 81, and then finally 122 over 82. So if you look at this, we could probably pretty safely start to assume. We could safely assume that the changes the changes that we saw in people's blood pressure was most likely based on the medication that that we gave them. Right, we prescribed them, because there's definitely a change in the blood pressure, as well as a consistent overall change in everyone's blood pressure, in the group 2, the active drug group, versus the placebo, right? And especially if I have a good average of everyone's blood pressure before. So yes, we could definitely say that there was a causal relationship between the results we had in between group 1 and group 2, again, the placebo versus the active treatment group. So that is what we would call a true experimental design. Now, you could get into greater questions of power. So the idea of how many people do we actually have in our research experimental groups in order to really say that this information will generalize to further to the rest of the nation or whatever. And so then you can get into those kind of questions later. But I just want you to understand the concept of a correlational study, again, which shows there's a relationship, but we don't necessarily know what that relationship is, versus an experimental group where we can actually say yes, not only was a relationship, but we can say specifically that this drug can actually do what we purported that we said it could do. Okay, so let's go back to our slideshow here. Okay. All right. And so the next thing I want to look at here is the concept of what's called independent versus dependent um, variables. And I think this is definitely important for us to kind of spend a little bit of time talking about, because the truth is that oftentimes people get really confused about what the independent variable is and what the dependent variable is. So to kind of make this easy, kind of an easier way to describe this, well, let's look at going back to the example of the blood pressure study. Um, the independent variable is something that we're going to be manipulating, right? So, for instance, this would be us giving the treatment group the drug, right? We give them the drug, and so that's going to be independent, right? Um, that's not actually going to be changed, right? Because we're the ones manipulating it. Whereas the dependent variable is the change that we're going to measure based on the treatment we provided. So this means that the change in blood pressure that we'll see either being in the placebo group or being in the treatment group is going to be dependent, right? That's why it's the dependent variable on the independent variable, which is the drug, whether they got the treatment or not. And so, easy way for me to remember this is the independent variable is IV. That's what's, independent is the I and variable the V there. So think about it like an IV that you put into your arm. The IV gives you the drug, right? That's the independent variable, and the dependent variable are the results of either getting the placebo or actually getting the real drug. Okay, so I hope that kind of clears that up a little bit there. And we've already talked a little bit about this, but I do want to kind of go into it a little bit more. Again, randomized assignments of participants is going to make sure that we have a valid test. Again, if I had a whole group of people come into my experiment, and I looked for everyone who had the lowest blood pressure to start out with to go into my treatment group, and then I found everyone who had the highest blood pressure go in my placebo group, then that wouldn't really be fair. We have to randomize the assignment of the participant. As well, we want to make sure that we have the randomized to the condition. That's what I was kind of describing there. And we also want to make sure that in order to prevent experimental bias, which is kind of here at the bottom there, we want to make sure that there's some kind of blind. Not only a blind to if is the person in the treatment group or not. If you're the participant, do you know if the drug you're getting is real or not? But also a blind for the experimenter, basically meaning that they don't know if the person they're meeting with actually is getting the real drug or not, and therefore, when they're doing their assessment of the progress and testing blood pressures, they're not trying to manipulate it one way or the other. Now, when we talk about significance of outcome, let's go back to my little example here. Let's say this placebo group is here, but let's say my numbers change all of a sudden. Instead of being something like close to that 120 over 80, what if I had something like 149 over 88 and 155 over 90 and 150 over 90 and 165 over 95. Okay, so what we could say is yes, maybe there is a slight reduction by being in the active drug group versus being in the placebo group. But I mean, when we're looking at this, the difference may not be significant, right? I mean, yes, we might see that there's a slight change, but I mean, look, we have 165 over 95 here, and we have 165 over 90 in the placebo group. So, are the difference actually significant enough? And so what we then get into is what this concept of what's called standard error, and is the amount of change less than 5% chance, right? So in other words, the change is if we're looking at kind of again the standard of error, is it less than a 5% chance that it could be just kind of variance in the type of blood pressure cuff we're using or something like that. And so it's definitely something we really need to ask is how great is the difference? Okay, going back to there.